Yes, good morning. I'm Tom Cram from NSF NCAR as well, and I'm a co-host with Monica and Harsha.
Yeah. So the main host of the session is, as you can see, online, and I'll let her introduce herself and the session.
Okay, great. Thank you, Harsha. So I'm Monica Einhorn Morrison, working online with Harsha and Tom in person, and thank you very much to both of them for being on the ground so that we can host this session. So I'm going to give a little bit of an overview to start of exactly what it is we're talking about in this session, and share the agenda with you as well. So hopefully that screen is visible and everything looks okay. So this is the session on epistemic infrastructure for responsible and reliable AI in Earth and environmental science. And you probably might be wondering what epistemic infrastructure is. It might be a new term, it might not. But epistemic is just a philosophical term for knowledge. And so what we're really talking about here is knowledge infrastructure. And the way that we see epistemic infrastructure is it is the scaffolding that underpins collective shared knowledge of data, of models, of tools. And here we're talking about these things in the context of the Earth system sciences or the geosciences. Part of the knowledge that makes up this epistemic infrastructure comes from things like formal publications, but a lot of it also comes from our practices within the geoscience and Earth system sciences of using data, models, and tools. Over time, we use those, we evaluate how they might perform, what their skill might be for different applications in different contexts, and that makes up a body of knowledge. And just as important is how we record, collect, disseminate, and communicate that knowledge. And this session is really about how we can be doing that for things related to AI and ML, as that is something that is moving really fast across the geosciences. Because the development of models, the development of data sets that might be considered AI ready, the development of these and the dissemination of them is something that's actually moving a lot faster than our ability to document critical attributes of these data sets, these models, and these tools. And real decisions are starting to be made on data and models where their fitness for those applications or those purposes has not been effectively established. So that's what we're going to talk about today, because epistemic infrastructure, as you'll see in the intro, where it kind of introduce what it is, why it's important, how we might go about developing it more comprehensively, really comes down to being that knowledge base that allows us to judge fitness of data models and various other sorts of tools for our purposes. So this is going to be a central concept as we go forward. And I just want to say that what we're doing today is we're trying to start a conversation about how we collaboratively and collectively build up this epistemic infrastructure, dedicate resources to it, mobilize it in the same way that we're mobilizing technical infrastructure around AI. And everybody is involved in this conversation, from people that are producing data to producing models to using data and models, engineers, scientists, practitioners. So these conversations ought to involve any actors in what we might consider the ESIP space. So just really quick, the session agenda, we're currently in the welcome. Then we'll pause for a minute, see if there's any sort of clarifying questions, although maybe wait for those. As I said, I'll give an introduction to things. What we're going to do, in addition to having our two talks, the second one's going to be given by Megan Rush, who's actually going to give an instance, a concrete instance of what this epistemic infrastructure might look like, is we're going to have time for questions, but also reflective prompts that hopefully will enable some discussion in the room. So we have a prompt that will come in between the two talks, but then a series of prompts and open discussion in response to those for the second half of the session. And then we'll just have a short summary and conclusion where if there's any sort of ending thoughts or things that people want to share out, we'll have opportunity for that. And one thing that I do want to show is that, and I'm not sure, I probably have to actually reshare my screen, so I do apologize for that. But our document is quite comprehensive. So if you go to that collaborative document link that we have, you'll see that for this session, we not only have the overview, but the prompts and the sharing spaces for those instances in which we'll be talking about and reflecting on various sorts of questions have their own space in the tab that can be found on the left side. And so each one of these boxes is just for you to kind of share your thoughts during the little brainstorming or reflection time. They can be anonymous. You're welcome to leave your name if you're comfortable with that. And then if somebody else puts something that you find quite interesting or that you want to highlight, you can actually just press the endorse right here. So that's kind of like the thumbs up that you would be using in Slido that you might have used in other sessions. So I will quickly stop there.
Thanks, Monica.
Mm-hmm.
So this will be emphasized again later, but right out of the bat, I would like to say that we have had many interesting conversations about generative AI tools in this ESIP, but this session's focus is on more predictive AI tools, and you'll know what I mean when the speakers get to it. I encourage all of you once again to check into the Google Doc if you're comfortable. And our first speaker is Monica. Take it away.
Okay, great. Thank you. Okay, so let me just pull up that second set of slides. Okay. So this is just going to be an in-depth dive of kind of what we're thinking about when we're thinking about epistemic infrastructure. One of the things that has been initiated at NSF NCAR is actually an AI initiative, where one of the central components to that is focused on reliable and responsible AI. My background is actually philosophy of science and ethics, and so I come at it from the angle of thinking responsible and reliable AI is really about being able to know the tools that you're using and make informed judgments about them. So I see epistemic infrastructure as key to being able to do that. So really the question that I think drives a lot of what we've been thinking about with respect to reliable and responsible AI that gets us to the point where we're thinking about epistemic infrastructure is concerning the fitness for purpose. A fitness for purpose of an AI ML output. And again, we're thinking about this from the perspective of kind of those numerical weather prediction models that are being developed out of places like ECMWF, out of NOAA, these foundation models that are cropping up, being put out there by industry that are based on petabytes of reanalysis, the hybrid modeling where we're inserting machine learning parameterizations into physics-based models, thinking about emulators. Also thinking about things like downscaling tools or tools that help us to visualize and map out risk. That might be included here as well as a form of AI ML that we're thinking about. But how do we know that, right, these things that we're using are fit for purpose? Well, we make a lot of decisions through the pipeline, decisions about what data to use, right, what we're going to train our model on, what data we're going to use and how we're going to evaluate and validate our model. And all this feeds into a downstream application. So, right, we have to consider fitness across this entire pipeline with respect to all the decisions that we're making as we're developing, disseminating, and putting into action these AI ML tools. And being able to answer that question, epistemic infrastructure is what makes that possible. Because as I'll show, epistemic infrastructure is really, as I noted in that intro presentation, kind of our collective knowledge about data sets, about models, about metrics, and various other sorts of tools that we might be using. And epistemic infrastructure, if it's done right, actually allows us to answer the question about fitness at various different stages, which is important because a lack of fitness with respect to one thing that we're doing across the AI ML pipeline actually propagates into the other stages. And as it propagates through that pipeline, it can actually become hidden and detached from that fitness consideration at earlier stages in the pipeline, which it becomes increasingly problematic because, as I'll demonstrate a little bit later, it can introduce hazards that have real epistemic and ethical consequences. As I defined a little bit earlier, epistemic infrastructure is that kind of scaffolding, right, that underpins our collective knowledge of the various sorts of instruments and objects that we use in the geosciences or earth system science. Comes from two primary sources, as I noted, but just to kind of go over that again. It comes from formal sources like publications where we have inquiry into the tools and we publish results. But it also just comes from kind of everyday use and tinkering with these various sorts of things. And also note that a lot of people that are using data sets and tools are actually not necessarily in a research space. And motivated by things like formal publications. So there's instances, for example, where people have used as practitioners the CONUS 404 data set that came out of RAU, which is a high resolution data set over the contiguous United States. And some of them are finding that there are these biases or these representational gaps. And that's reported in their talks in the white papers at the institutions or organizations where they work, but they're not necessarily found in formal publications. And so a lot of these uses, a lot of these applications, this knowledge builds up, and we need to make that something that people have easy access to, and to collect it in a singular place. So epistemic infrastructure not only collects knowledge from use, but it makes that knowledge findable. So it's collected, it's disseminated, it's communicated in specific ways where we have what one person is learning becoming part of that collective body of knowledge, and making it and reaching those contexts that others might be working in where they're using the same sorts of data sets, models, and tools. So just as important as developing that knowledge or getting that knowledge is the dissemination, communication, and collection of it. And that's what makes knowledge infrastructure able to actually answer fitness questions. But what knowledge infrastructure makes possible in a more general sense is it makes data sets and models legible. So data models can not only be located, but they can be well understood so that we can make informed judgments about their appropriate use and we can use them responsibly. This is why this is key to reliable and responsible AI. So these things are not buried in a format only that creators can access and interpret. And this information is also not buried and fragmented across like the vast number of publications that are coming out about data sets, models, and various other sorts of AI tools on a daily basis. It enables the evaluability of data sets and tools. So you can here actually make a judgment based on what's been documented in the information that's collected about using those things in a specific context for a specific purpose, given a specific set of stakes. So the assessment kind of no longer lives in the abstract. The information is right there for you to employ in your decision making and have a warranted judgment. And it allows for accountability too. So data and models are attached to something and there's responsibility when something turns out to be inadequate. So these are important components of what this epistemic infrastructure can make possible. So one of the things that we've been doing, as I said, with respect to this reliable and responsible AI initiative that's coming out of NCAR, is thinking about kind of what epistemic infrastructure might look like and consist in. And so what I've kind of currently done is envisioned a grouping of frameworks that are largely focused on getting at things that matter for fitness for purpose judgments, because that is the central concept here that I'm working from, and thinking about these frameworks being operationalized through various sorts of kind of community collective knowledge objects. So one thing is this data fitness framework, where we're looking at trying to identify the various sorts of attributes of data that go into being able to make an informed judgment about its fitness for a particular use, defining those, relating them to one another, and constructing kind of a formal ontology. And then seeing how we can operationalize that through something like a metadata ontology that's in a machine readable format, but also how that might live to some extent in data cards, where we're documenting various components or attributes on data cards in ordinary language so that various sorts of users can not only have things in the metadata that are machine readable if they want to automate what they're doing or making it visible to AI. But people can also just consult these ordinary language sort of documentation and make informed judgments there through descriptions of the data. And dimensions of fitness, because we've already kind of started thinking about what are these fitness attributes that might matter that people need to know about for data sets and models. We've identified 6, some of which communities have been working on for quite some time, some of which are a little bit newer and come from kind of philosophical discussions of the nature of data and models. But we have various things like representational fitness, which is a characterization of how well data might capture phenomena, conditions, regimes, or extremes that are relevant to an intended use. There's statistical fitness, which is a statistical behavior of data and models, which also accounts for various things like uncertainty, bias, and error behavior, and its adequate characterization. We have spatiotemporal fitness, which is probably one of the ones that is quite obvious. This has to do with the spatiotemporal resolution and coverage, the scale of the phenomena, its drivers, relative to an intended use. One of the ones that is specific to kind of AI models is dynamical physical fitness. This is consistency with physical constraints and theoretical understanding. So one of the talks yesterday talked about the importance of intelligibility so that we can understand kind of the underlying causal network that AI models are picking up on. That would be a way to determine whether we have dynamical and physical fitness in the sense that we need to have it. Relational fitness really has to do with consistency across data sets, vocabularies, ontologies, and then provenance and contextual fitness, the ability to have transparency and clarity across the entire transformation of a data set or the pipeline or life cycle of a model. And so why fitness matters, just really quick, is that if we have data that's unfit for purpose and that it carries various sorts of gaps in representing instances of extreme at the spatiotemporal scale necessary to capture what's happening with respect to extremes for a vulnerable population or region, we train a model on this. It underestimates the severity of drought for that location. People use it to make decisions about water resource, but this leads to them being misinformed or there being a misrepresentation of what the extremes actually look like that they're making decisions around. We get the decision being that less water is actually allocated to regions that are experiencing greater amounts of drought because of that underestimation. And we can get something like the exacerbation of already existing injustices. So thinking specifically here about data, fitness gaps can amplify across the AI ML pipeline, as you can see in this example. And that can lead to epistemic harms, where we have things like inadequate, erroneous predictions, misleading, or information that obscures certain things that are important or that we care about. Ethical harms, maladaptation, resource misallocation. We can have false positives, false negatives, exacerbation of injustices. And this is a cascade of consequences where data inadequacy, which is essentially the inability of data in terms of maybe its representational fitness to have that like lowest threshold met, can lead to model failures, which leads to errors in decision making and actually has material consequences in terms of harm. And if we're thinking about fitness, right, this is actually kind of a natural extension of FAIR, which is already operating in ESIP communities in the data and the Earth system science communities. And it's most naturally kind of an extension of when we're talking about R, reusable, data and models being reusable. Because reusable asks, can this be reused? Whereas epistemic infrastructure really just tries to allow us to answer the question of reused for what? And is that actually a justified use? Do you actually have fitness that can be demonstrated? And that's what these elements of epistemic infrastructure allow us to answer. So FAIR, right, is something that we've been using that is converting tacit knowledge about where a data set lives, how it was built, what its lineage is, into some sort of shared explicit structure and knowledge base. And epistemic infrastructure is just essentially doing this for fitness, those things that I showed you earlier. And the meta point to make here is actually with respect to some of those elements of epistemic infrastructure, so those data cards, those metadata ontologies, those readiness badges, stamps, whatever we might want to call them, those things actually also need to be subject to FAIR's criteria. So they need to be findable, they need to be accessible, they need to be interoperable and be reusable themselves. So there's kind of FAIR, we're extending it, but we're also applying it to the things that we're developing that are part of that extension. And also want to point out that this is not new to the community. These are things that we've already been doing, although maybe not in the comprehensive kind of like explicit sense in which I'm trying to get us to recognize we need to mobilize towards. ESIP has the AI ready data checklist that is already getting at some elements of fitness. So this is that community built guidance that covers things like data quality, data documentation, access, and preparation. So there's a lot of FAIR kind of considerations built into that checklist. It's for individual users to kind of evaluate their own personal data sets, but it includes considerations of things like data set bias and uncertainty and whether you understand that and how it might impact the work that you're doing with that data set in the AI ML context. There's also croissant and geocroissant. So that's the shared metadata vocabulary to make machine learning data sets interoperable and discoverable. NASA extended this to actually make it fit for use on gridded data sets for observational data. And there's things like biases and missing data, as well as spatiotemporal sorts of attributes that are supposed to be documented in this metadata. And then there's FAIR for ML. Which extends FAIR for ML models, so extending it past data sets. It has a schema for describing models, their way that they've been evaluated, their kind of history of transformation and validation. And some of the fields actually in this metadata are things like social ethical consideration, risk bias limitations, and actually explicit kind of ordinary language comments about intended use. So they're already kind of getting at some of these things that we might need for fitness. But I would think that we can probably extend that a bit more. So there's a really interesting article, data sheets for earth science data sets, that also kind of gets at some of these fitness attributes. But what a lot of this documentation is doing is getting us to describe what a data or a model is. So focusing on its resolution, its coverage, its performance, which is great. But if we want to enable people to make judgments, informed judgments about fitness, there's various sorts of kind of negative attributes that might undermine fitness that we also need to capture. So these are some of the ones that kind of we've been brainstorming about at NSF NCAR. So documenting contraindicated use cases, what this should not be used for explicitly. If somebody finds that they've applied it and it leads to error or something happens, that needs to be explicitly documented. Observational and representational gaps. So these are the known coverage gaps, regions, regimes, extremes. Uncertainty to structure, not just that there is uncertainty, but actually describing it and its sources. Another big one is error bias. So type 1 versus type 2 errors, and giving people information about whether data sets might, with respect to a certain phenomena or statistical property, skew towards false positives or false negatives. And then other things like field-wide known limitations, if there might be potential relational inconsistencies across data sets, that sort of thing. So what I want to do is I just want to leave this up here. This is just kind of a quick consideration of, this being a community-wide sort of collective effort where we need to think about kind of who's responsible for what if we want to mobilize and get towards building this sort of infrastructure. There's data producers, data users, AI ML engineers, and the community at large. Probably the community is the one that we want to think about in this context with ESIP. And the community is probably the group that can standardize fitness assessment protocols, develop shared evaluation frameworks and documentation standards, and even implement trainings on things like responsible use, development, and dissemination, because this kind of fitness really ties back to responsible use and responsible development. So making that apparent there. And I'll just leave this here. So that's my name, that's my contact, and that QR code actually gets you to the responsible and reliable information about the NSF NCAR AI initiative if you want to get a bigger picture of kind of what we're doing in that space. All right, so I'm going to stop sharing.
Let's thank the speaker. Thanks, Monica. Do you want to lead us through the reflection prompt?
Yeah, do you want to pause and see if there are any sort of questions about that? And then I can throw up the prompt, or I can throw up the prompt as people might think about questions. We don't have a Slido or anything, so if you're in the room, you have to raise your hand, and then if you're online, I'm monitoring the chat, and I believe that I also have Tom on with me to help me grab any of those questions. But yeah, let me throw the prompt up here. So the first one is actually just kind of trying to get you to reflect on, oh, that was absolutely the wrong thing to do. Sorry about that. To kind of think about fitness, right? What fit for purpose might actually look like with respect to a data set, a model, something that you might be using in your own work. Just thinking about, what sort of attributes would that thing have that would allow you to say, well, this is fit for my purposes? So what sort of things would need to be highlighted? What sort of properties might that data set or that model have? And so if there are any questions, we can take those, but I do want to give you a moment to pause to kind of think about fitness, if that's maybe not something that you've thought about in an explicit sense before, what that might look like in your own work, or how you might characterize that. And I will also say that if you're in the room or you're online and you want to just kind of share as you're reflecting, that is also an option.
Hello, can you hear me, Monica?
Yes, I can. Hello.
Okay. Hi, this is Maddie Allen. I'll actually do this. Okay, there we go. Hi, this is Maddie Allen. I'm in the room with everyone. I have heard you speak or in the chat for a few different sessions. That was an awesome presentation. And I had a kind of like immediate question that kind of ties into this reflection as well. So I thought I'd just ask it now. But you kind of were saying, okay, this fitness for purpose, it's with a specific data set, a specific use case with specific stakes on the line. And I guess I can just picture like I think this is super important to be thinking about. And I love the idea of having some way to kind of more systematically evaluate this and document it so that it's available for folks. And I guess I just can quickly imagine it kind of like spiraling a little bit out of control in terms of there's just so many specifics to consider for a given use case, that like if you wanted to kind of host a data set that you really wanted to have be used responsibly, it obviously wouldn't be possible to consider every possible kind of level of this. So I guess I'm just trying to picture like how that would actually play out when there's just like thousands of different use cases that might need to be considered, just in terms of the scope. Is that more of like you're kind of picturing it as a mainly kind of community-based like approach once people are actually trying to use it and running into problems and kind of doing a good job documenting that? Or do you envision like the folks that are kind of hosting a data set or putting things out there are like doing their best to kind of stress test it a bunch and then document that? I would just be interested to hear any of your comments on that.
Yeah, that is an excellent question. And it's something that I've kind of grappled with in thinking about how we go about this, because you're exactly right. You cannot in any way anticipate all the possible uses of a data set or a model. And I actually come from the world of Earth system models where, we've been trying to implement something related to kind of adequacy for purpose, and just anticipating what an Earth system model might be used for is just, this almost an intangible exercise. But so what I'm thinking is two things. So I do think that to some extent there needs to be some sort of documentation from the producers, right? If the producers know what the intended purposes of their data set are, and they can make a judgment about, well, you ought not use it for this, given that I developed it along this pathway for these purposes. That kind of contraindicated use is something that they can put down, right? But with respect to various sorts of uncertainties or biases, if we're thinking about something like Earth system model output, it's the community that largely in their use collects that sort of knowledge and documents it. So these things like data cards and model cards would essentially be living documents that the community would contribute to as they use these sorts of things. But I also want to point out that kind of, there are tons of considerations when we're thinking about whether something is fit for purpose, because this is a highly relational sort of thing. But I think that there are certain things that if there is a lack of fitness or a lack of adequacy in terms of a data set or a model with respect to that attribute, like representational fitness with respect to like an extreme, there is an increased risk if that is used in a context in which it's not fit for. So what I'm trying to do is I'm kind of trying to hone in on these especially high risk attributes that we need documentation around, and thinking about how we can get the community to kind of maybe more explicitly keep records of those sorts of things. Does that make sense?
Yeah, that.
Yeah, that makes a lot of sense. I have so many thoughts, so I'll pass it off to others, but I might follow up with you later because
That would be
this is
that's
great.
Awesome. Okay, perfect.
Thank you.
Glad you like the idea.
Hi, Kathy Todd Brown from University of Florida. So I was I'm a little curious how you would think about building a community, and I'm going to call it a community of practice, around developing and maintaining these standards. Oftentimes the easy part in my experience is developing the code list or the knowledge graph or whatever. And then the hard part is building community momentum, both around adaptation, adoption, and maintenance of these. So I was wondering if you had any thoughts on that.
Yeah, so I do have some thoughts. I think that, one thing would be to kind of prototype some of this and try and demonstrate the value, because I think that, this might be seen immediately as kind of bureaucratic overhead a little bit. But one of the other speakers actually made this really interesting comment where he was talking about, people think that, metadata is just paperwork, but it's actually infrastructure. And as you become somebody that's working within a field where you rely on that metadata, you start to understand its importance and its value. So the hope would be that, like, through something like GDEX, which is the geoscience data exchange that we host out of NCAR, we could maybe, start playing around with something like, model cards or data cards that document some of these attributes in the hopes that people would see the value for their own work and maybe want to participate in trying to do that as they go to their own sort of work. Yeah, it's not a very good answer. I've actually tried to work with CMIP on mobilizing some of these things, and it is kind of like, this is not meant to be offensive or anything, but like, getting a very old, like, lazy dinosaur to kind of change, its route. And
yeah, I was going to follow up with the idea of a model card or a data card is not particularly new. Like there's been a bunch of efforts around this, and I'm curious. It might be an interesting exercise to take a look at how some of those tried to convene community around and failed to do so. And because I can think of at least 3 efforts that I've been involved with in my relatively short career that just didn't get traction enough. Maybe it got some audience, but it never got any community contribution or engagement. So I think that from my perspective, that community building piece is kind of the pain point or the secret sauce that we're still trying to wrestle with. So
yeah,
it's a great talk.
Thank you. No, and I absolutely agree, and that's something I definitely need to work on. And I think the suggestion to kind of maybe learn from previous initiatives that have not been able to get up momentum, that is an excellent suggestion. And so I might actually just ask you, if you don't mind, if you would go into the document and kind of like list ones that you're thinking of that I can follow up on. Because it would just be great to learn from that and to kind of think of a plan that might be able to overcome some of the barriers they experience to adoption. Thank you.
Good morning, Lou Mayo, Gamma One Technologies. Great presentation, enormously important.
Thank you.
As we start to rely on AI models, predictive models, with greater, accelerated fashion. So I have a question, and this is in the area of space physics. It turns out that AI predictive models do a pretty good job, or well, let's say a better job than the physics process models in predicting solar storms.
Okay.
Great. Now, let's say I want to validate that AI model. Well, the general mechanisms that encompass solar processes are pretty well known. Magnetic reconnection, general solar plasma flows, all pretty well known. But the trigger mechanisms that produce solar storms are not well known. They're widely debated. How do you validate a model? Yes, the AI models seem to do a better job, but how would you validate that if you don't understand the underlying physics? Maybe that's a difficult question, but there you go.
No, it's an excellent question, and I think there's actually something analogous that we grapple with in like Earth system modeling. So right, a lot of people are developing these numerical weather prediction models that they're saying, oh, they can go out to like a month, 2 months, right? We have this like extended predictive capability, and a lot of times, right, they're showing empirical accuracy, which is what you're describing, right? So I have consistency with observation. It looks like they're doing really well. But if we try and probe, what are they getting at in terms of processes or in terms of drivers of these things that they're predicting? It's actually really difficult to kind of validate or evaluate a model in that sense, because like we don't really understand the drivers and the teleconnections. So the way in which we know that high SSTs in the Pacific lead to a heightened like El Nino, but sometimes it manifests, sometimes it doesn't, right? And so, we have a sense that there are these relationships, but we can't actually explicitly represent them even in our theoretical understanding of the system. So I think that, to some extent, we need to do the best to do process oriented diagnostics, but where we might actually be lacking that theoretical understanding, unfortunately, I think that what we have is the same that we have for our physical models, which is empirical accuracy is going to be kind of the thing that gives us confidence, and as we gain a better understanding of the system, we can actually look at process representation and that sort of thing. But we grapple with this with our physical models, where empirical adequacy is a necessary but not a sufficient condition for having confidence in a model's ability to perform, especially in out-of-sample conditions. So yeah, I guess I don't really have a good answer. But yeah, I don't know. Sorry, it's an excellent question, and we grapple with it in Earth system modeling too. And yeah, just faith, I guess. No, that's a bad answer. Sorry.
All right. In the interest of time, we'll circle back to questions. Okay, one last question. Yeah, go ahead.
Oh. Okay, my question is very quick. So my name is Zhong Liu from NASA JASDISC. We're also facing the fit for purpose challenge. One thing is you might want to include users in the loop. For example, like you buy some item in Amazon. People give you a lot of reviews. So That way, you probably can understand, fit for purpose, Yeah. I know, a lot of users, behind the scene, they do a lot of their own evaluations. But the problem is it's difficult to collect. We need a platform, to collect those reviews.
Yeah, that's an excellent suggestion. I think we do, like, even with respect to the framework and these sort of, important attributes, we do want to kind of stress test that with users to say, are these the things that you care about? Because, I'm making the assumption this is what's important from kind of a philosophy of science perspective, a perspective of responsible use. But we definitely need to consult the users and get feedback on the frameworks and then how we're trying to mobilize them. So thank you for that suggestion. Okay.
Thanks, everyone, for the great questions. You'll have a chance to ask more questions to the speakers, but we want to hear from the second speaker, so I invite her to share her screen. Meg?
Okay, it might take a...
Yeah. Yeah, so our second speaker is actually Megan Rush, who is a contractor for USGS and has been working on developing AI-friendly data set documentation. And so when we're thinking of kind of, how we want to capture things about these data sets, make it machine readable, so that kind of these attributes can be carried through the AI pipeline, Megan's actually going to give us an account of kind of a concrete thing that they're doing with some of the data sets out of USGS. So Megan, I'm going to hand it off to you. Your camera's not working. I don't know if that's...
Oh, well, my presentation is now taking up... I'm going to stop sharing.
I think maybe for now it's okay to just share your presentation and go through it. And then when we go to questions, maybe you can just take your presentation down. Oh, well, your camera's working now, actually.
It's working now?
So maybe,
okay.
Yes. Yeah. Okay, that's perfect. Thank you. I appreciate you troubleshooting really quick. Okay, off to you.
Okay, so I work for KBR as a contractor to the USGS, specifically on the Landsat project. So this is about documentation for Landsat data. It's going to cover a little bit formatting as well as content. I work in an environment where documentation means Microsoft Word, PDF publishing workflows, and not, Markdown and GitHub. And then content, so documenting a diverse data set that spans many decades and many sensors. So first of all, formatting. So my documentation environment, you first have to create it in Microsoft Word, and then peer review through comments in Word, tracking changes, accepting changes, and then convert it to a PDF that's 508 compliant for the web. So that meets accessibility guidelines. My workaround, I still have to create, peer review, and edit in Word. The PDF version still goes to the web. But once the document is approved for publishing on the web, I use Pandoc to convert Word to a GitHub flavored Markdown. And there are several Markdown options available through Pandoc. And then, so this is for the upcoming collection. Landsat kind of reprocesses everything in collections. And collection 3 is one coming up in several years. So we plan to host this Markdown in GitLab, so similar to GitHub. And some tips for a clean conversion is to use the default word styles and bullet points. As far as probably not new to everyone, but when you're creating a document, kind of have a blank slate. You're not filling out a metadata template or a data card template or anything. How you organize it is very, very important. Not just the syntax of getting this right, but what order the topics go in, what topics you choose to include, what you don't choose to include. And this covers, so this document that we're working on kind of combines something we call the data format control book, which just talks about the format of the data, as well as the product guide, which delves into more caveats and limitations of the data. Some guidelines for tables, like no images or screenshots of a table, and just insert it in Word, paste the cells from Excel, and don't include long tables. There should be a separate CSV document. I don't know I don't have a specific guideline on how long is too long, but one of our documents currently has like a table that spans like 20 pages, and not in collection 3. That is going to have to go in a separate CSV document. Some tables might be serving as visual aid. Maybe it's something that was made in Excel to get that layout, but it's an image. It's not really a table. So those should be saved as images. And in Markdown, they need to be saved as an image with the location reference. So my advice is to use images sparingly in any documentation that's intended for Markdown. And now, documented a data set that contains diverse data. So this could be that it's aggregated from different sources. In my case, it's similar data from different sensors or different generations of sensors. So the documentation needs to include guidance on, how the user can determine which data within the data set is fit for their purpose. So this relies on fields in the data itself or in the metadata. Some of my examples here are, it should identify what source or sensor it came from. So the metadata should include, for each observation where it came from. If it was like a CSV data set, it could be one field in the record could identify that. And in the case of Landsat, there's a metadata file. We have a stack record, for instance, that describes the TIFF files. And then the documentation should include the explanation of differences between those sources or sensors. I don't know if any of you are familiar with Landsat, but if you're using our 1970s sensor MSS versus our current sensor OLE-TIRS, there's a huge difference. Well, it should include limitations, known issues, caveats associated with that particular source or sensor, and any additional quality indicators that might be only available for or really only applicable to some sources or sensors, and their quality indicators will have slides on that coming up when I will explain more. I have an example here of what this identifying the source or sensor looks like, both in the stack metadata. It lists the platform and the instruments there, and then an example of what text and documentation might look like. Just explaining that Landsat 8 has 2 instruments, OLE and TIRS. That most products contain data for both, but some only contain thermal data from TIRS, or only the rest of the spectral data from OLE. So then if the user is looking for surface temperature, for instance, they know to look just for TIRS. And then quality indicators. So the metadata, and I'll give some examples of what quality indicators are. And it could, depending on use case, it could be a lot of different things. It could be cloud cover, it could be sun elevation, could be a quality indicator in some cases. It can be, in remote sensing, the kind of transmission or downlink quality, especially on our early satellites. That's a big issue. So the metadata should include the field names and the values for various quality indicators that apply. Some will apply to the whole data set, but others will only apply to data from select sources or sensors. And then the documentation should include an explanation of each quality indicator and implications of the values in the quality indicator field, as well as how to use the quality indicator field. And I have another example of here. So in the stack metadata, it says cloud cover, and text and documentation, let's say something about what the number in that cloud cover reflects. And this one is pretty obvious, but just in case anyone doesn't know, that means that any pixel covered by clouds won't be an accurate measurement of the Earth's surface. And then, note that you can use the cloud cover field to find products with minimal cloud cover by filtering your call on the Stack API. The documentation could go on to to include, some code as to how you would apply that filter in your Stack API call. This is my last slide. I do not have a end slide, since this is really just the beginning of the discussion.
Thank you, Megan. This is Harsha Hampapura from NCAR. I have a question. So can you shed some light on how you arrived at these best practices for AI-friendly dataset documentation? Because we have had a lot of discussion on getting community input. So, yeah.
I think the place that I work at has the advantage of having, all of the developers who develop, the software that processes the data, as well as, like the science users, people who are using our data in, sometimes in AI and ML models, like all sitting in the same building. So I have access to all these different people. There is, of course, a much larger community that uses Landsat, and I certainly haven't received feedback from all of them. But so part of it is actually Gen AI driven. It's making sure people who are using the Gen AI tools to code are able to, read this information in the format that the AI tool most likes, and making sure all the information, the fitness for purpose, fields available are included. And, I think was not any mystery that we needed to include them in the metadata, but maybe tying the metadata in the documentation of how to use them, what they mean, what the implications are, might be a little bit more new. But it has really been a lot of this feedback has come from talking to science users, people who are using our data for different science applications, that sit right next to me.
Thank you. Yeah, go ahead, Monica.
Yeah, I just want to hone in on that last point, and actually what you have here is your example. I think it's really important to have that relationship and that connection between the metadata and then the ordinary language documentation that aids in the interpretation of the metadata. Because I feel like metadata, given how kind of simplified and formalized it is subject to misinterpretation. So, you kind of have to have those sorts of constraints around the responsible use of the metadata itself, which is why I really like this example of the text and documentation that aids, right, people in their understanding of the metadata so that they can be as informed as possible as to what that's actually describing, and the implications of it. So yeah, I really like this. I just want to say it's great.
Thanks. And after your presentation, I now have kind of language to apply to what kind of a quality indicator is it.
Oh, cool. I like that.
All
right. So,
other questions for either of the speakers? Thoughts on epistemic infrastructure or the particular example that was shown?
Yeah. At NASA Earth Data, we have a DPDG data product developer guide that include a lot of metadata requirements for data producers. So if they don't provide this information, it's very difficult to, for data curators to create and, yeah. So instead of each agency do their own thing, I think ESIP would be a very good, platform to do this kind of, make this kind of recommendation. So save, because I spend a lot of time, with the DPDG working group, yeah. So I think it would be nice, since we need to share our data, across different agencies. So each agency have their own different, standard metadata. It's very difficult to work with data integration, cross-disciplinary research.
Yeah, we're actually in the process of trying to get Landsat data into a part of Earth data for that highlights kind of international data providers, and since we primarily use Stack instead of something like ISO 19115, it's a little bit more tricky to get it in there, and probably would require some extra work on Earth data's part to get it in.
Can I follow up quickly with a question to, and I apologize, I don't know who just asked the question, but Megan, this is also for you. To what extent do you think that there are these kind of different standards operating for metadata requirements that are a consequence of the fact that different agencies are producing different data types, right? And so data types from different sorts of instruments, different observational data types. So in situ, satellite, different satellites, that sort of thing, kind of have different sorts of requirements for what you need to document in order to describe the data. So I'm just wondering if you think that kind of these diverse standards have emerged because of the diversity of data types that different institutions are dealing with.
So I don't think the kind of the core standards like the ISO 19115 or the Stack necessarily emerged from needs of different data types, but I think maybe different extensions in Stacks and there's similar thing to extensions in ISO. Probably the extensions and the fields they choose to use and variants of these standards did come about because there's different data sets with different needs.
Mm-hmm.
I don't see any hand raises in the room, so okay.
There is a comment from Maria that just popped up in the chat. Maria, do you want to share it with the room? I can also just read it out.
Yeah, do you want to go ahead and read it?
Yeah, so NIEHS has created a catalog of geospatial data products relevant for wildfire health research. Sorry. Finding detailed metadata about temporal and spatial resolution, model, update frequency, etc. was very time-consuming and required manual curation. So unified formats would be very helpful. So yeah, I think just having cross-agency agreed-upon standards across metadata, at least for fitness fields, might be something that, because I think some of these are newly emerging, so it might be something that we can do. Although need to, as one of the people in the room noted, need to learn from past failures for sure, to see how we can get the community collectively working on this sort of thing in a successful manner. Thank you, Maria. Okay. Oh yeah, Maria, go for it. I see your hand raised.
Yeah, just as a note, if there is a working group to develop this unified format, we are happy to share the metadata template that we created, developed for this catalog.
Okay, perfect. Thank you. That would be great just to see what you've developed and what your thoughts are. Okay, Harsha, do we have any other comments or questions in the room?
I don't see any immediate reactions, so I guess you can move on to the next second prompt.
All right, cool. Megan, can you stop share? And I'm gonna go on. Thank you. Appreciate that. So the remainder of the session is kind of just dedicated to having some sort of discussion, but allowing you to have a couple minutes prior to engaging in a wider conversation to just kind of reflect on certain things. So I'm just gonna pull up, as Harsha noted, that kind of second prompt we had. So first prompt that we had asked you if you just had any thoughts about what constitutes fitness with respect to the sorts of things that you work with. This one asks you just to think about, in your experience or maybe in the experience of colleagues, have you ever encountered an instance in which data or model was not fit for the purposes that it was put to? And to maybe elaborate on what some of the consequences were. So what was that lack of fitness, and what were the consequences of that lack of fitness? Was it because, I mean, we can have lots of different things happen. You can have incorrect information. It can just provide bad data. You have to go back. You have to reform your study that you've done. Can also have cascading consequences that where there's some sort of material harm that comes about, economic loss. Can also be things like, a false alarm, stuff like that. So just kind of think about that sort of thing, and what it was due to in the data set or the tool, what wasn't fit. And then, yeah, maybe if people in the room want to kind of share out their examples.
Can I put you on the spot and request you to share an example?
Oh my gosh. Yeah, I can think of a lot of examples actually.
Go ahead.
So, I mean, I just know of an instance in which, so I don't know how many of you know about Earth system models, but they're pretty coarse resolution. But somebody took a single model, which is a huge no-no, because you want an ensemble, because models have various sorts of structural uncertainties and representational assumptions in them. So you want multi-model ensemble when you're using model output, especially to inform decisions, or inform you about risks, stuff like that. But somebody took a single model and they were trying to get an idea of what drought would look like in a specific basin in the Pacific Northwest, and also just took a single grid cell, which aggregates across everything. So it kind of washes out the extremes and various other sorts of things, and gave that information to farmers as something that was usable to help them understand, on a decadal scale, what their changes to precipitation patterns in the area might look like. And thankfully, this information wasn't used because of the lack of representation of extremes, and because of the mismatch in spatiotemporal scales, the information was just not usable. But it downstream led to kind of a lack of trust in models, because somebody chose a model that was unfit for purpose, and the models were seen as, defunct and unusable. And so that was kind of a consequence, the erosion of trust between, people on the ground, model developers, and then just the lack of usability of information, that somebody was trying to provide something that was actually, useful. Yeah, Dave, do you have one that you want to share?
Hi, can you hear me okay?
Yes, we can.
Yes.
Yeah, okay. Hi, I'm whoops, let me get it back. Hello. One of the things that I'm really concerned about is that we work with a bunch of decision makers in the private sector and also in state emergency operations centers that have discovered AI, and they have no technical or science background. And so, they're putting in information that they want to find out answers to make decisions. And sometimes they're big decisions, whether they're going to send, 100 utility bucket trucks down to this certain area to help restore power. And without the science background and the natural questioning of AI, I really am concerned about how this evolves, in the future. And I just wanted to get your thoughts on it and how we can approach the non-technical side the non-science side of those folks who, put information into AI. They get out really nice looking products, and they trust them because they're really good looking.
Yeah, I mean, this should be a question for the entire room, but I'll take a stab at it real quick. I think that to some extent, this is where things like model cards, right, can actually be kind of powerful, because a lot of times, people are sold on AI, especially with these numerical weather prediction model emulators that keep cropping up that, oh my gosh, look, you have this empirical, adequacy. You got consistency with observations. You have more consistency with observations, or this accuracy with respect to these models than with some of the physical based models. And that looks really good, but a lot of these are not like what we would call valid benchmarks for the sorts of uses, right, that people want to put these models to. So being able to kind of be honest about, we haven't validated this in this way. There's these limitations that we might not know about. There's these tendencies for error, right? Because actually having that concretely spelled out in ordinary language, where when somebody adopts a model, that model card is right there, right? And easily accessible and findable. I think that would help. I think there's also a little bit, and I don't know how to rectify this, but I think there's a disconnect between, right, what users are having as their criteria for trustworthiness and what actually makes a model reliable are. So I'll go back to one of the comments that was made in the room about the models that are being used for like solar storms, those emulators, where they make pretty pictures that look real, right? They're high resolution. It, looks like the real world, these sorts of things. But we don't know what's going on under the hood, right? But we have a tendency to think, a reliable model is one where it's capturing the right processes. It's actually representing the physics, that sort of thing. So to some extent, I think that we need to figure out like why there's this distance between model reliability and what's actually deemed trustworthy in AI, and try and bridge those a little bit in the way that we're communicating about models, and we're presenting models and things like that. And I don't really know how to do that. I just know that there's this disconnect that exists. But social science studies might be able to help us understand, why there are these indicators that users have to place confidence in a model, and why those are sometimes not warranted judgments when we actually look at what criteria for model reliability are, I guess, if that makes sense. Oh, Dave, you're muted.
Of course. I always think that ESIP might have a role to play here in putting in, whether it's metadata or some sort of information that can be passed along through the AI channels that provide that level of make sure you trust this, make sure you double check this. I mean, the large language models today say, oh, we make mistakes, so check your work. But I think that, the wave of AI is happening so quickly. There's good looking products being put out there with bad information in them. So
yeah,
just wondering where ESIP might be able to play a role. Thanks.
Yeah, I think there's definitely a role to play. And I think one thing that requires a little bit of a cultural change is that we have a tendency to, really display the wins, but to not talk so much about the failures, and be open about model failures, model deficiencies, things like that. And I mean, there's a bunch of different reasons for that, especially now, if you're working in Earth system science. But if we can have more transparency around, oh, this hasn't been validated in this way, or we don't know this about the model, so exercise caution here, or being honest about, caveats with respect to model use, that would be helpful. You don't really see a lot of that, though.
Yeah. Thanks, Monica.
Yeah.
Hi. Hey, Monica, this is Doug Schuster, NCAR. So I think this is a great discussion, and I think the whole context, what is an authoritative source of information is a challenge. I was at the AMS community meeting, which is brings together private sector, public sector, National Weather Service. And some of what Dave was talking about came up. There was, a disaster preparedness person from a county center, and it's just like one person that works there. So this is like a real-time decision thing. Where do they get their information to make decision, and what is fit for making a decision? So that's one use case. So, as we think about this, do we need some kind of plain language summary like you have for AMS or AGU abstracts? Mm-hmm. And then there's the scientific fitness for purpose of how do I use this in whatever my retrospective research is to, be informed to create a product that, has good context in terms of its provenance and what was used to, come up with an end research finding. But the first one is really challenging because think about it. Like your kid asked Alexa, what's the weather today? And it tells you what it is, but I don't know where that comes from. And there were some studies, at this meeting that said it was a combination of Channel 9 News plus Weather Service plus raw model output. And then you see, people posting crazy images of whatever a deterministic model says is going to happen 7 days out on social media just for influencing. I don't know how we capture all of that, but I think a starting point is at least having information that says what this should be, for the deterministic model. This is not a weather forecast, period. Don't use it as such. It's used to inform weather forecasts. So those are the things that came to my mind. But having the information is a starting point. How do we communicate it? That's a whole different ballgame.
Oh, yeah. Yeah, absolutely. And I'll just say that's why one of the things that I think is really important to capture in metadata and then have on model and data cards is that contraindicated use purposes, right? Like just they're clear, like this is not intended for this purpose. And I think that, we can't anticipate all the purposes that something will be used for, but I think that we can easily flag ones where there's high risk if this is used in this context because it constitutes gross misuse of this sort of thing. And we do not currently capture that and communicate it in any sort of way whatsoever, because that I think would be a big step forward.
Lou Mayo Gamma 1 again, loving this conversation. Let's just keep doing this all day. I'm really taken by your comment. We tend to emphasize our successes and minimize our failures. It occurs to me that's what soothsayers do. They predict 5 different presidential elections and they get 4 wrong, but they get 1 right, and that's all over the front pages. Dave, it's great to see you on the silver screen. 2 thoughts. First of all, if you have non-technical, non-scientific people evaluating the, I'll call them the AI models, and the AI model is a black box, does it matter whether you have a science background or, you don't know what is going into this decision. It turns out in retrospect, perhaps, that the model did a very good job in predicting whatever it is, whatever physical situation you're looking at. So it's an interesting question, but at least for me, I find myself just looking at a very dark, opaque curtain when I try to understand what the AI models are doing. I don't know. I have science understanding, a little bit of technical understanding, but I'm not sure if that's any better than Joe Blow on the street. I think it's hard to know how these models that appear to be successful are coming up with what the models that they produce.
Yeah, I think that's a real challenge. And the one comment that I have is I think that, we need to have transparency around models, and we need to understand why they're doing what they're doing, right? Because, a model can easily, and we have this with physical models where we get consistency with observation, which is our go-to for validating, models, especially predictive models, even if we don't understand what's going on under the hood. And even our physical models will have compensating errors. And so you'll get consistency with observations, so accuracy, empirical accuracy, and then the model will be doing something totally physically implausible underneath. So I would actually say, and this is what I've been arguing for, which is why I think we have responsible and reliable as part of this component of the AI initiative at NSF NCAR, is that empirical accuracy is necessary but not sufficient for deeming something reliable, especially if we're using a model in a context that is an actionable context where decisions might be made off of the outputs that you're getting. And I would say that intelligibility, right, and there might be very different degrees of it or different, criteria for intelligibility, but that is also a necessary condition, right, for deeming something reliable and placing confidence in a model. And so we kind of need to get away from this epistemology where, like, if something is consistent with observations, I'm going to trust it, because history has taught us that, that is not an indicator of the reliability of even physical models. And so I think we need to rework kind of, what our reliability frameworks look like, and then try to communicate that downstream to users through examples of, hey, this model did really, really great with runoff in the Colorado Basin, but then we actually investigated what it was doing, and, it did this physically implausible thing, and it just happened that there were compensating errors when the output was calculated. So, like, if you're using this out of sample, which, I come from, dare I say it, the climate world, but if you're using this out of sample, absolutely not. Like, there's no reliability there. So, yeah.
This is Coral Howe from USGS. I have some thoughts. I think, like, it comes down to how much error are we willing to live with. Like, we see this in geospatial world all the time, where people zoom in into a shape file that is never meant to be a foot. Like, the scale is never meant to be seen closer than 24,000 inches in the surface. And we live with that. And the data is implemented in local models, regardless of whether it's the right fit or not. So I think that it's not correct, but we're willing to live with that for whatever reason, because it's what we have, is the best guess or concept that we have. So I think we need to narrow it down to, like, how much are we willing to sacrifice for getting whatever information or analysis we want to get to it.
Yeah, I think that's really important, because we are constantly grappling with these various sorts of, like, trade-off decisions, right? And so am I willing to sacrifice a little bit of accuracy as long as I can avoid this sort of error over here? But I do think that's kind of an adequacy for purpose decision in and of itself, right? Because, like, you might have certain thresholds for error or uncertainty, but then another user might say, oh, no, I don't have those thresholds. So I would deem the same thing inadequate for my purposes, which is why I think, and I had it as statistical fitness, but, like, there is, like, error and uncertainty fitness. That's something that we grapple with in Earth system modeling, physical modeling, on a daily basis when we're trying to see if products, Earth system model output is going to be useful to downstream users, is that uncertainty question, right? That error question, like, is the tendency for this to overestimate precipitation in this area something that, is adequate for your purposes? Or are you taking on too much risk and using something that has these sorts of consequences in your decision making such that it's inadequate? But yeah, those are definitely questions we need to be asking, and we need to be thinking about fitness relative to these trade-offs that we're willing to make. So that's great comment. Thank you.
So again, Kathy Todd Brown, University of Florida. So I think that one thing that we're wrestling with are these shifts for use cases and sort of what we're asking our different products to do. 20, 30 years ago, we were just get it out of the filing cabinets and digitize it and then slap a label on it so it's discoverable. So it was really metadata for discovery so that we weren't, the paper containing the information was not rotting in a filing cabinet somewhere. And now we're asking sort of these same repositories to now serve the purpose of training these AI models and kind of thinking about these large data pipelines and how do we surface this contextual data that we need for analyzing our AI outputs. So I wonder if really what we need to be thinking about here is kind of how do we construct these metadata standards in a way that bakes in this concept of iterative improvement. So 30 years from now, we're going to be asking different questions of our data sets. So how do we have a process and procedures in these standards that is evolving and iterative? And maybe there are a couple of different levels of standards. Maybe there are different communities stewarding different types of standards. But yeah, I would really love to hear more people talking about not just static standards, but evolving standards.
Yeah, I like the idea of not only the objects we creating being kind of living so that they're constantly being updated and improved, but also the standards themselves, right? Being something that, as we see these technological and cultural shifts and these epistemic shifts, like we revise and approach things differently as the world around us changes. I do think that that's something that, yeah, we need to be doing, especially with the accelerating technologies and all these things that are coming about.
John Liu again. I think one key information is missing here. So if a modeler or data provider can provide information regarding your product, key limitations, key strengths, and make this information available to users. For example, we know a lot of AI models, they are not good. They don't perform well in extreme events, but not many people know that. And sometimes this information can be buried in literatures. It's very difficult to find, So also this information needs to be updated as well.
100% agree. All model failures that I know about don't come from the people that are provisioning and disseminating these models. It's the literature, and it's fragmented, and it's difficult to find, and we need to figure out a way to collect it. I've actually been looking into the history of documentation around radiosondes, and they actually have an incredible culture of epistemic infrastructure around these instruments that I feel like we can learn a lot from and possibly adapt, because they really, really knew what they were doing in terms of their collective knowledge, documentation, and dissemination practices. It's actually quite impressive, and it's almost been a century of doing it around these instruments and objects. Yeah, so if anybody has anybody that works with radiosondes, send them my way so I can learn more about that. Yeah, I want to give people in the room an opportunity, and Megan also, if she wants to comment on any of this, to do so, since we're coming to time quite rapidly.
Yeah, I was just going to say, great discussion, Monica. How do we continue to engage? People are interested. How do we continue to engage the ESIP community amongst others on how to best proceed? Because this is a great topic, but it's also challenging on how to implement something like this operationally. So what are your thoughts on how do we continue community engagement?
I mean, one thing is that we actually now have an official project where at least we're going to start kind of working on data fitness. And a lot of that will be community engagement. And so I would just say that if you're interested in continuing these conversations and thinking about what do we need to document, how do we mobilize the community towards transparency and communication about these various sorts of things. What do these objects need to look like in order for them to be effective, both for people that might be using data sets for their own research, but also for AI, because I think AI just kind of exacerbates the problem of fitness in ways that are unexpected. I would say, please put your name in the document, and maybe we just have some periodic discussions to continue the conversation right now. If that can be supported by ESIP awesome. I'm actually very, very, very new to the ESIP community. This is my first ever thing I've ever done. So I don't really know how things work, but I don't know, maybe there's a working group. I don't know. But I think if people are interested in continuing this conversation and they see this as a challenge that they would like to discuss and figure out how we can mobilize around it, just give me your contact and I will lead us into the trenches. No.
This sounds like an ESIP cluster. I'm
just
plant that seed.
I'm not gonna lie, I don't know what that is, but if it sounds like an ESIP cluster, maybe that's the direction that we go to continue the conversation.
And just to follow up on that seed, the machine learning cluster currently isn't doing that much. So maybe this could actually tie into that already established cluster, which I'm the fellow for.
Oh, sweet. Okay.
And the soil ontology and informatics cluster is currently working on, we're calling them resource cards focused on semantic standards in the soil space. So anyway, and I have shared that cluster for a while now.
I was at that I was online for that one, and that I think ties in quite strongly to some of this. There's different things you're trying to document, but you definitely have something that's well organized, well managed, and well structured there that I think we can learn from for sure. That's a very impressive GitHub.
We've got one final quick question or comment.
Yeah, just a quick comment that there is AI readiness cluster in ESIP, and it's like, Megan is there, I'm in that cluster, and it's very related. So, well, yes, we need more conversations like that. I'm also a little bit concerned about multiplication of clusters and people kind of spreading thin, and the important conversations not happening within the same kind of groups that discussing very adjacent or like similar topics.
At the risk of putting more meetings on people's calendar, the idea of having a coordination node between the ESIP clusters is something that I've been wanting for a while now. The fellows and the ESIP staff do a great job of trying to connect where they can, but having dedicated space for clusters to talk about similar efforts would be useful.
Yeah, more exchange of information between clusters, for sure.
This is Harsha from NCAR. I would like to add a comment. ESIP clusters are great, but I think we need a mechanism for people to asynchronously comment on whatever standards that are being developed for either for the epistemic infrastructure or the AI readiness, right? So not everyone can be at these meetings, but should make it easy for people to participate. And it's a solved problem. Like there are GitHub discussions, forums. There are many ways to do this.
Okay, thanks, Harsha. Megan, I want to see if you want to pop in here and have any sort of concluding thoughts before we end.
Since the AI readiness or data readiness cluster was brought up, I just want to chime in that that's a good place to discuss, for data providers and specifically like how we should be including fitness for purpose in our metadata and our documentation. So if anyone's now interested in joining that, feel free.
Thank you. Appreciate it. And thank you, Harsha, Tom, for being on the ground, coordinating everything, co-hosting. It's very, very, very much appreciated to have you guys.
Welcome. Good discussion.
No, thank you, everyone. Thank you, Monica. Thank you, Megan.
Yeah, thank you. And really appreciate all you in the room participating, even though it was a hybrid conversation. So thank you for taking the time.